Doctor, draw.
Yes, shall we start now? I think we're getting late. Hello.
Wait, sir. Actually, I just talked to Raju, sir. So we need to make an announcement in that simultaneous class, which is going on GoToMeeting. Okay, so all the people will join. It will take like 2 minutes. So you may start after like 2 minutes. Sejal, please ask Rishika to make that announcement. I just left that meeting.
Okay, sir.
Jaskaran, who is recording? Are you recording? Jaskaran?
Yes, sir.
Sir, Rishika is recording.
Okay, okay, Uditi. Okay, okay, okay. So Sejal, please let us know if Rishika made that announcement in that meeting. Okay.
Yes, sir, was taught. Sir, Rishika has announced it. People may take a minute to join here.
Okay, okay, okay. Okay, okay, Uditi, go ahead and introduce Reddy sir, and I think we can start,
Sure,
right?
sir. Yes, sir.
Yeah, and Raju sir, are you here? Because I have seen. Wait, wait, just. Hello, yes, sir.
Good afternoon, everyone. I welcome you all to the second day of the short-term online course on applications of machine learning and deep learning in data science, being organized by Center for Continuing Education, NIT Warangal, in collaboration with Department of Mathematics, Sri Venkateswara College, University of Delhi. Sessions for day 2, as given in the schedule, will commence as planned.
Okay, Uditi,
Dr.
go
Reddy,
ahead, start. Yeah, 50
yes,
people
sir.
is there, so most of them are here. Okay, so go ahead and start.
Yes, sir. Sessions for day 2, as given in the schedule, will commence as planned. Dr. Reddy, sir, from NIT Goa, will be taking over the first session to give a lecture on the topic NLP for data science. All the participants are requested to maintain the decorum during the teaching. Wishing you all a smooth learning experience, I now request Dr. Reddy, sir, to please take over.
Thank you. Am I audible? Please confirm.
Yes, sir, you're audible,
Yes,
sir.
sir, you are audible.
Yes. So this session we are going to talk about the brief motivation to natural language processing and what and all the various research challenges and then complexity involved in natural language processing and these various other applications. How we are going to achieve or solve these problems and get some applications out of this using some machine learning or other data science applications particularly. Before going further, may I know who are the participants exactly, the background?
Sir, actually, we have undergrad student, postgrad students, research scholar, industrial personnel, and some faculties as well.
Okay, I think the mix.
So almost 50% is undergrads,
Okay,
and the rest of the batch is in the other 50%.
fine, fine. So I assume at least many of them know the basics of NLP or at least the concepts of artificial intelligence and all, right? At least the basic part.
Yes,
So
you can say that those who are here, they have some knowledge about
yes,
the subject. Yeah.
yes. So now to begin with NLP. Now if you see like many of the machine learning solutions which we
Hello,
provide for some real-time problems. Uh,
hello.
now, yes, any problem?
Sorry to interrupt you, but we are just new to the natural language NLP. I'm
Yes,
not
sure, madam.
from that background.
I've got it. I have got that mixed. I
Yeah,
mean,
yeah,
mixed audience are there.
yeah. It's new
So
for
try to
me.
cover from the basics, like what and all the basic concepts, and then what and all the applications. Here, don't worry. I'm not going to talk any. I mean, high-end techniques because for the time being, only I would like to give some motivation to the domain and how we can use some machine learning models here. Okay. So I think you will have some conclusion at the end for this. So to begin with, now you see wherever you see any research problem nowadays, we want to compare like previously we were solving without some machine learning or some data science related application. Now with some AI applications, then what is the change? Now when we talk about the domains like natural language processing, see particularly over the last one decade, we have seen a lot of growth in this domain, natural language processing. First, let me spend some couple of minutes. What is natural language processing? Now you see, we speak something, right? Is it a natural language? Obviously, it's a natural language, like a collection of some text or some words, some sentences, some paragraphs, whatever it is. Now, when we talk about understanding this particular language, natural language, and use that particular understanding for some real-time application. When we go for natural language processing, first we are collecting some data. That is a natural language data, some text document or some any other, whatever it is, some voice, input voice signals, uh, kind of data. Then I use that data to understand something. For example, I'm going to develop a system where the system is going to record the voice signals, I mean, input audio signals. I'm going to say what is a conclusion, just one line conclusion, what the entire summary of this one. Or I'm going to say some editorial article, like some newspaper. I will read it for a while and see what is the conclusion. And next thing, whether it is biased or unbiased coverage of a newspaper article. Is it a natural language that we use in newspaper article? Say yes or no? It's a natural language, right?
Yes.
Similarly, other applications. If we talk about like if it's the current pandemic time, when we talk about nowadays everything has become online. Particularly, treatment has become online, and sometimes because now like people prefer contactless treatment, contactless teaching, something like that. So this type of human computer interaction models have become more popular. Like I say something, computer will understand something, and then accordingly it will give some reply to me. Like I said, these are my symptoms, like high fever, some body temperature is this much, some heavy cough, so and so. Then my pulse oximeter, the value is something. Then it will try to understand my natural language. Then it will interpret something. It will analyze first, then interpret it. Then it will make some conclusion. Based on the conclusion, the computer will suggest the suitable treatment. Fine. So this is a kind of natural language processing we want to say for some human computer dialogue systems. Similarly, online teaching. Somebody is teaching here now. For example, if I type in YouTube or somewhere some lectures for operating system, thousands of lectures will come. Which one is good? Which one is bad? Obviously, the input is natural language, but the question is whether computer can understand natural language. Say yes or no. Tell me. Whether computer can understand, because the natural language is the most toughest language than any programming language. Do you all agree with me? First and foremost.
Yes, sir.
Yes, sir.
Yes, sir.
Obviously, programming language int x. There is an integer, name is x. It has some bytes of memory that we can store. That's all. But if I say some natural language statement, we can interpret 100 meanings in that, right? That's why programming language processing is obvious. It has only deterministic meanings. When you go for natural language processing, it has a lot of meanings. Like when a person is saying, I'm your very best friend. Is it really true or not? We don't know. Only that person knows. Processing the natural language is really very challenging. That makes this domain is still survive. So I mean, still growing every day. And the applications are even interdisciplinary. When we talk about NLPs, we always consider interdisciplinary. It's application we can do it in forensics and then defense and then sentiment analysis and then other medicine, biology, everywhere. Of course, we are going to see at least 20 applications today. But the question is, please try to understand, why do we really need to process a natural language, I mean, data that is given to you, maybe in the form of some text document, some document files, or some voice input signals given to you, or any form of data, but it's a natural language processing. How do we understand what the user wants to convey, what the person wants to convey by his natural language? What is the meaning of that? Because when we can develop such an accurate model that can give you exact opinion or the purpose of the language that a person is speaking, we can make a lot of applications. Not only like light detection, like I say, like somebody is speaking, it's his own language. If you can understand the language and process and say whether it is genuine speech or not, we can make highly sophisticated applications out of this particular data. So data is simple here. Natural language is simple data. But the challenges are very diverse and interdisciplinary and complex also. That makes this domain very, very popular nowadays. And applications are, like I mentioned, plenty of applications we're going to see. So here our job is we get to our model, we get some data, natural language data. It could be in any form. Okay. different local languages, different other languages, different text document, different. It may be in the form of document or some audio signals or any other form. So how do we understand that data? Then which particular model we are going to use according to the type of data we are taking. Fine. Then using the model, what type of predictions or what type of analysis we can have here for some real-time application which you have chosen. It is just understanding some words, because now you see, if you can develop a model, some natural language processing model that will identify the language by many people. Yes, you're not audible clearly. Please let me know if you have any doubts.
Please, someone mute this person.
Please, all of you, mute yourself. If you have any doubts, that is fine. Otherwise, please mute yourself.
Yes, sir, we are on it. Please carry
Yes.
on.
Now, when we talk about the complexities, like what we are talking about, all these things, our job is to go for such an practical applications to develop or to identify from the natural language test. And there is something called intelligent processing, because just processing of a conventional, language or any other programming language is different than processing the natural language. That's why we call it the intelligent processing. Okay. Of written human language. Now, mostly when we talk about NLP applications, we talk like we work on intelligent processing, developing a model where we can intelligently process the natural language, mostly written human language by a computer, mostly. But natural language could be in any form, any natural language data that is given to it, may be a voice input signal also. Okay, so there are plenty of applications, particularly in the concept of in the time of this pandemic. We have a lot of scope for working on this natural language processing related applications. It's for online teaching and virtual patient monitoring system, and then some other forensic applications, plenty of applications. Now, coming to the type of data, like I already mentioned, there are various type of natural language data given to you. Now, sometimes if you see, like programming language, natural language, similarly we have something called pseudocode, where we use a mixture of programming and natural language. So our job is to collect such a type of data which we are going to use for analysis, then extract some information from the data. Now, you normally see, this is a perfect example for your knowledge discovery process. How do we extract knowledge or patterns from the data? Normally, your data, everyone knows who has studied conventional data mining course or even DBMS also. So something that could be in any representation or any form, maybe in raw form, whatever it is. It's an outcome of some experiment. When we take data, our job is first to extract the information from the data. Because many of your undergraduate students, so let me highlight this. Conventional knowledge discovery process, when we talk about, our job is like, I have a natural language test, I'm going to extract some information. From information, I'm going to extract knowledge. What does this mean? Try to understand. Now, see, I have data, like data of some students of a particular class. I have their names and age and gender details, etc., etc. That is my data. It's like raw data. Everything is mixed up. Now, what is information there? If I say information, like out of 100 students in a class, some 10 are girls, 90 are boys. That is the information. Data is 100. Information is what? 10 plus 90. Are you following me? Data is 100, a class of 100 students. Information is what? 100 out of 100, 10 is girls, 90 is boys. Fine. Tell me, what is knowledge now?
Sir, which adds meaning to the data, is that information?
Data, I say, like data, I have some raw representation, like I have a details of some 100 students in a class. Now, I say I will extract information from the data. Then what is my information here? Like out of 100, I'm going to see the each and every student, like out of 100, 10 are some female, 90 are male. So I say, like, this is like same, this is the same information we have, same kind of representation, but in a better form. So that is known as something better data we are extracting. That is known as information, something somewhat crucial compared to the remaining part of the data. Now, what about knowledge here? You tell me, if I say 100 equal 90 plus 10, 10 female, 90 male. Now, what is knowledge here? Knowledge normally we extract from the information which comes from the data. Tell me, what is knowledge here? Anybody? Why I'm saying this example is only then you can understand what is natural language processing.
Processed data is the information.
No, I'm not in this example. Like there is a class of 100 students. It's a raw data. I have no idea who are these 100. Now, when you go for information, little bit better data, like I can say, like out of 100.
Knowledge is like
Hmm.
how many males and females are there in the
Yes.
jungle.
Sir,
Knowledge, I can
we
say,
can say knowledge is a 90% of
But
out
we
of
have
90%.
10 girls.
yes, knowledge is like I can say there are more. I mean, male domination, like you can say, female representation is less. Do you agree?
Yes, sir.
Yes.
Data
Yes,
is what.
yes,
See now,
Yes, sir.
now my question is: can you get knowledge directly from the data?
No, sir.
Yes, sir.
If
We
I
No, no,
want
can.
no.
to,
From
We have
information we
to
get.
arrange it
We
first
have
with
to
information,
drive the
then we
knowledge from the data.
yes. So if I look
short.
the
Someday.
whole data as a whole, you will not be able to get the knowledge. Knowledge comes by analyzing the information. That's how you have to go in the knowledge discovery process. Data to information to knowledge. Then finally, based on knowledge, you can take a decision making process. Fine. This is how knowledge discovery in any conventional data mining process happens. Now, coming to the natural language processing, our job is what? A natural language, some raw conversation. Fine. Now, from that, I'm going to extract some information. Okay, some keywords, some key phrases, some sentences which are very crucial. Then knowledge I'm going to make. Okay, based on these keywords, these sentences, this particular known as features. Okay, let it be. Then I'm going to make some analysis and understand something about the initial data which you have taken. That is known as your knowledge discovery, how we can make it. For example, if I take some editorial document, some newspaper or some TV, whatever it is, some editorial document, text data I'm going to take. That is my data. Now, what is the information here? From that editorial article, I'm going to just look upon some keywords like some parties, political parties names, some VIP names, and then some biased or unbiased key phrases I can take. Then I can look into this information that comes from the entire editorial article. Then I can say I can get some knowledge discovery. What? Okay, based on this editorial article, based on this key phrase, I can say this article is likely to be biased or unbiased. It is supporting a particular political party or not. Okay, so this is how we make the knowledge discovery. This itself known as processing. Like take the data, get some information extracted from there, then make some knowledge out of this one. Now tell me, where do we require these machine learning models? To extract data to information or information to knowledge? Tell me.
So can you please repeat
Information.
your question?
Now I have given some multiple examples like what is data, what is information, what is knowledge. In a natural language processing scenario, I've talked about like you take some editorial article data. What is information like some keywords, some key phrases, some political parties' names, some VIPs' names, some sentences which can represent. Then that is the information. From information to knowledge. Finally, what is the article says? A two-line conclusion after analyzing the information which you extract. Fine. Now my question is, while coming from data to information or information to knowledge, where do you require, where do you have, much need of these artificial intelligence or machine learning models?
Information to knowledge.
From
Yes,
to knowledge,
yes,
information to
Yeah.
knowledge.
information to knowledge.
We should
Somebody
have a
use data to
capability to
information also we
analyze.
require. Yes, you're right. More analysis is needed when we come from information to knowledge. Normally, data to information when we talk about, it comes like almost in some deterministic form. When you talk about information to knowledge, it's more analytical in nature. Fine. And knowledge to wisdom, known as some decision making process based on the knowledge discovery make. So these levels you require more analytical models for your like some AI or machine learning or other data science elite models, everything. Okay. So this is very important. How we are going to make the correlation and how we are going to make some predictions. Then finding the patterns, and then patterns like some features, some correlation, some relation, some understanding, some analysis, all these things. So it is very, very important. Are we clear so far?
Yes, sir.
Any doubts, please let me know if you're not understood what exactly natural language or what is natural language processing. And see, natural language is different, natural language processing is different. To process them, we require machine learning or some artificial model for some better accuracy, whatever it is. Okay. So my job is natural language processing is what? Given an input natural language data, how do we analyze them and how do we solve the given application? That's all. Now question is how to solve the given problem. Like when we talk about nowadays, any research problem we are addressing, first and foremost, what we do, I'm going to look into, the help from artificial intelligence or other machine learning related applications. Obviously, only if at all I cannot find any suitable, it is not like that every problem in the world can be addressed with some artificial intelligence model. May not be. Most we try to depend on that because most of the problems we can solve in a better manner. See, before AI, we solved many problems. After AI, we are solving using AI. Does not mean that we cannot solve any research problem without using machine learning. No, not like that. But at the same time, once you give some NLP document with you, I'm going to use for some application like human computer dialogue system or some virtual patient monitoring system. Like doctor can understand what a patient is saying and he can give a possible treatment to him, something like that. Even though he cannot understand the language, if a doctor does not know the language, still he can treat the patient. All these applications. Now the question is, which machine learning model I'm going to use it here? That makes it. Now tell me, I'm not going to discuss what is genetical, what is fuzzy logic, what is farm intelligence, what is deep learning and everything. But normally tell me your option for this. Whether you go with some neural network or some genetical algorithm or fuzzy other type of model. Normally, what is your choice? I'm sure some of you may not have studied machine learning models, but still those who are at least aware, just let me know. Whether you go with some neural networks or fuzzy or any other type of models. How? Obviously, deep learning is very effective. I can say that. But why and any other option is in your mind? Because this is a research topic. It's not like a regular classroom topic. Please try to understand. Get a
Sir,
motivation.
we can go with neural networks, like multi-dimensional neural networks.
Yes, obviously we can choose neural network. That's a really good answer and it's the right answer. Compared to others, neural networks maybe, but sometimes fuzzy modeling also, because now actually mostly knowledge is like linguistic type in nature. So fuzzy also can be opted in some cases, but compared to fuzzy logic, neural network or deep learning models are more effective. Obviously, because there are a lot of user students over here. Now, why do we require neural networks to be very effective for this type of NLP problem? Somebody tell me, please. Let this session be interactive. Huh? Please feel free to share. Neural networks, yes, that's the right question, right answer. Now tell me, why neural networks? Anybody, please? Okay, I think all the participants know the basics of neural networks. Is there anybody who is not having any idea about neural networks?
Sir, can you please give a brief idea about neural networks? I am
Yes, just
able to
it's
understand.
this is not a talk on neural, but I'll just spend 2 minutes time on it. Now, see, basically, what is the main job of neurons in our human brain? Tell me, anybody?
It connects information from transmits messages
To
through neurons.
transform information. To
Basically,
transform
we
It
can
information.
does
use neural
Receive
network
everything.
for face
Storage,
recognition,
memory, information,
also for
everything.
stock market prediction.
That is application. But mainly, the main purpose of neurons is learning. Do you all agree with me? Learning is the main job of neurons, the main responsibility of neurons. Why? Because, like, if I see a person today, I will see his face. I will remember some features, like his face looks like. I will learn Okay, this is the name of the person. He looks like this one. I remember. Remember is nothing but learning. After learning about the features of a face, you are remembering. You are going to your office every day, right? One day you just first day you feel some difficulty. Second day it is slightly easy for you. Third day it is even easy for you. Fourth day onwards you can directly go. But because your brain is learning, nothing but your neurons are learning what some features like, okay, this way goes left, then you right, then left, then right. So you're training your neurons, they are learning. So the main responsibility of neurons is learning when they are trained. Fine. So the artificial neural models which we have evolved, then normally how it works, if you train the brain, fine, if they train the neurons, now what they are learning, when we learn, what will happen? Knowledge will be given to us. Fine. So the whole concept of artificial neural model is to just adopt this behavior, how the central nervous system works, how the nucleus functions, how the dendrites works, how the axons communicate, how the hillock, everything. Of course, there is a biological neural model. Those who are interested for this artificial neural model, they can still go through that. So in artificial neural model, we adopt this behavior of training and learning, and we use this particular behavior to solve some real-time problem. Now, what do you mean by training and learning for our natural language problem talking about? You see, I'm going to develop a communication system like a human computer dialogue system, like human computer communication system, like some voice assistant. Sometimes if you call somebody, there is a computer operator is asking some press some number, some next press some other number, like that. Or similarly, if there is some voice assistant system like, okay, welcome, please specify your name and age and date of birth, etc., etc. Then what happens when you say my name is so and so, my age is some 28, then this when you say this 28 with some different accent, the computer should be able to identify, recognize your voice input signal and use, I mean, collect the exact features and identify that, which means what, it is already trained for that. You just try to understand now why we are going to use neural networks here. I'm training previously, like somebody is saying my age is this one to a computer, a voice signal, then computer will understand this voice signal something like this, and it will say, okay, this is like 28 to 8. So we are training the computer previously. Fine. Then based on the training, learning happens. The next time, whenever any new person comes and say, my age is so and so, it will clearly, I mean, get the voice input signal and interpret it exactly what is the age of the person who is speaking. Then what are the symptoms of him? He may say, I have fever. It will exactly read the natural language, I have fever. Then it will interpret it into, now when say like somebody, I have a fever, when it is understood by a computer, it will be understood in a natural language or in a programming language, or you can say machine language. Tell me, when a user says something to a
Natural
computer,
language.
it will understand the natural language, but it will understand finally in which language?
Machine.
The
Machine
machine
language.
language.
Machine.
First, it
Programming
will
language.
convert that natural
Machine
language to
It
language.
will
machine language.
convert it into machine language and
Yes.
then
So first it will see what is the voice input signal. It will convert that voice input signal or what is a natural language, whatever it is, to its desired machine language. Then it will understand. It will directly may not understand. Fine. So now we are training already using some neural networks. Like when the person say my age is something, my weight is something, I have fever, all these things. It's a treated. Obviously, you can ask a question. What will happen if I all of ask an unknown question to the computer? Obviously, what happens? It is not trained. It will not work. It can say, sorry, I can't hear you, speak again. It's a dialogue system, natural language processing application. It can say, sorry, I can't hear you, please repeat again. Again, you say the same thing. Since it is not trained, how many times you ask the same thing? Now, I'll ask a simple question all of a sudden. Have you heard of Alexa, Siri, and others voice assisted systems? Have you heard?
yes, sir.
Yes, sir.
Are they working with or without NLP processing? Tell me. What is the base for that? Is it not NLP?
Yes.
Yes, sir, it
Yes,
is.
sir.
Yes,
Yes,
sir.
sir. Yes, sir.
They are very good example, good system example for natural language processing. But are they perfect? No. They're mostly trained to some general questions which you ask, like because I have seen some of my friends are teasing with Alexa, like asking like some some unusual questions when they ask. Sometimes it's say, sorry, I can't hear. Sometimes it's say, sorry, I don't know. Whatever it is, some kind of answer, because they are not trained for that direction. Fine. So limited training on natural language, mostly what and all the possible questions a user can ask to such a voice assisted system. That direction they have trained. So like I mentioned, this neural network is one could be, and similar way people try to use some fuzzy logic application also. Why? Because now natural language is mostly fuzzy, I mean linguistic in nature, right? Linguistic in nature. So this type of linguistic analytical processing, we also use sometimes fuzzy logic, because like you say, I say like he's very good. It's a natural language statement, right? How much he is good, I don't know. Exactly, the person who is speaking, he say good. Good is what? Like exactly in your opinion, like how much rating will you? 1 out of 10 or 2 out of 10 or 5 out of 10? So this type of linguistic analytical processing, you might need fuzzy logic modeling, or in case you want the efficiency of both, you can combine some neuro adaptive fuzzy inference system type model. Neuro fuzzy system, they can work better sometimes. All these applications we have. So neural networks is my first choice. In case it is not giving some good accuracy, maybe you can go for some fuzzy logic related concepts with different membership functions. But normally we have seen deep learning, when we go with normally without data, there is no deep learning we have, obviously. So what we require? We require some large amount of data. Normally what happens, some good amount of handful data, trained data. I've already mentioned neural networks. I have to train first. Then I will learn. By means of training, I will learn. If it is very important. So if those who are going to use deep learning type or other neural network architecture, they can have some large amount of data and some good amount of training data, of course, at the same time. And when data set is limited, we have other options also, because when the training itself is limited, then I can't go with neural network models, obviously. I've already mentioned about that. Then I have to find the alternatives. And there are several other approaches. We have transfer learning and unsupervised pre-training model, semi-supervised learning model, many other one-shot and zero-shot learning model. Plenty of the machine learning model, but of course, it's a home pitch, those who are working in the domain of machine learning. Now, finally, goals of NLP. When we talk about, normally when you are implementing any natural language processing application, we have multiple goals, mostly scientific side and the engineering side. So in the scientific side, when we talk about, mostly I have to identify the hardware requirements, and then what type of communication interface needed, etc., etc. For exhibiting the kind of linguistic process which you try to have in your engineering goal. We try to design a model to process the given type of natural language, subject to subject, and time to time, location to location. It can get changed, right? Say if there is one model that can work on some type of subject, same may not work for different subjects, because natural language is highly uncertain and uninterpretable and difficult to process also, and it's linguistic in nature, person to person. Therefore, designing a model that can have high coverage of subjects or people language, then implementing how to implement such a complex data on different models, and testing how the testing can, because testing is very important here, and because we are training and learning, then we are going to launch the product. How the testing can perform, everything is also important. Now,
Sir, one question. Sorry to interrupt.
yes,
Sir,
yes, please.
sir, what is the how the neural networks differs from deep learning? Is it deep learning consists of many neural networks, or it's different from that?
We have next coming slides on deep learning, but since you have asked now, I'll say now. See, deep learning now by name itself. Now, if see, normally you have seen conventional these neural networks, feed-forward neural networks, and other multi-layered networks and all. Now, when we talk about deep learning and convolutional neural models, see here learning. Normally, this learning in neural network happens later. Now, just let me show whether I can have a small video. Give me watch 1 second. Huh? I will just check whether I have. Just give me 1 minute. Huh? I have some small video. I'll just play. Try to look at that. You will have, you can understand. Can you see the video? Please confirm.
Yes, sir.
Yes, sir.
Yeah, we can see it.
Audio, I'm not sure. Let us let me check whether audio can come or not. But let just go through the video first.
Nervous tissue. Objective: to learn about the nervous tissue and its functions. If a person unknowingly touches a hot object like a kettle, she immediately pulls back her hand. Why does she do this? This happens as the receptors present in the fingers sense the heat from the kettle. The sensory nerves in the fingers absorb this impulse and transmit it to the spinal cord. From the spinal cord, this impulse passes to the motor neuron, which in turn passes this impulse to the affected muscle in the finger, and the person immediately removes her hand from the kettle. This whole process involves coordination among the nerve cells called neurons. These neurons are found inside the spinal cord and the brain. Now let's learn about neurons. A neuron consists of a cell body called soma. The soma is enclosed by the cell membrane and has a nucleus. There are several thin, thread-like extensions from the cell body called dendrites. The dendrites receive impulses from the adjoining neurons. The other extension from the cell body or soma is a single-branched extension called an axon. Each axon is comprised of a cone-shaped base called an axon hillock that arises from the soma. At the other end, the axon is divided into many branches, from where the signal passing through the axon is transmitted to the other cell via a junction called a synapse. Thus, the information is received by the dendrites and is then sent out through the axon to the neighboring cell. This is how information is transmitted from one cell to another. To summarize,
Yes. Have you understood this small video where we have seen the functioning of a neuron?
Yes, sir.
Yes, sir.
Yes,
Now,
sir.
talking, you see, now we have seen, see how the communication among the neurons happens, and how they communicate via the axons, one cell to other cell, and every cell has a nucleus. Now, when we see this deep learning type of architecture, mostly see the similar learning happens. There is no much, difference. Only thing is, this type of learning happens at different layers, more than one hidden layer we try to maintain here. Like the reason for having this multiple hidden layers is like what? You are making iterative learning and try to get a better accuracy, because when you go for this type of layer by layer learning, by just updating the weights and optimizing towards, you are going to have a better classification accuracy in your deep learning model. So it's like a next level computation, but obviously it will take, a little more computational complexity, unlike the conventional neuron models. But the advantage is what? The accuracy is always high when you talk about the deep learning architectures, when you go for. Okay, but the number of hidden layers, how and optimizing the hidden layers and all these challenges will be there. But at the same time, if you keep the computational aspects aside, but mostly the accuracy wise, these deep learning architectures are more. But in computation side, there is no much difference. Computation side, when we talk about the style of computation is almost same. Only it's iterative layer by layer learning process where we are going to optimize the weights and then going to get a better classification accuracy from this model. That's all.
Thank you, sir.
Yes. Still, we're going to have few more slides on deep learning. I will explain further there. Now, coming to this question, I've already highlighted like what is the scientific goal towards the NLP application and engineering goal. Now, tell me where most of the research is going on as of now.
Healthcare.
No. Scientific point of view or the engineering point of view?
Engineering point of view, I think, sir.
Scientific point.
Actually speaking, engineering point of view, many of the models are being designed and implemented, and some systems are being developed. But see, when we want to say like, I'm taking some natural language process text and developing a, AI model, it have some good amount of activity. But at the same time, this computational machinery or the required hardware interface and how to make such interface successfully, that again scientific point of view still a lot of gap is there. But most of the research is going on the engineering point of view. Because for example, applications like smart teaching or online teaching using natural language processing type models, and then this virtual patient monitoring system, or some smart Android application or whatever it is, where 100 patients at a time, a doctor can address 100 patients by just taking their natural language data. And similarly, these human computer dialogue systems, and similarly some e-commerce applications, like when you launch now, you can say now we have seen like a lot of recommendation systems for e-commerce application. Now similar way, recommendation systems with respect to the user communication and user and the computer communication, whatever it is. So all these applications, lot of researching, but at the same time, for this application you have to go for some scientific development at the same time. Whenever I'm going to, see some e-commerce application to buy some clothes or to buy some glasses, sunglasses or whatever it is. Same time, I should also require some computational measure which can make it give better exposure to the user. Like if I say I'm going to look for so and so type of items, it will understand my natural language and say possible, what is the possible recommendation system. No, but this again, when you go for e-commerce application, they could you have to go NLP plus recommendation systems as well. Okay, but at the same time, you require some sophisticated, customized machinery to achieve such an application, where a user can have the real-time feel of the item he is going to purchase by interfacing or by interacting with the computer that is there. Okay, so engineering point of view, lot of research is going, but same speed scientific point of view is not, but still a lot of research is going on either sides, but mostly towards engineering goal. Okay. Are we clear so far?
Yes, sir.
Now we have to have a lot of prerequisites to, like I mentioned already, this NLP is very interdisciplinary. You have to understand, may not be in depth, but some basic understanding of these subdomains you have to understand. Only then you can play with this type of models. You should have a good understanding of phonetics, phonology, where you're going to understand the language sounds, because in language sounds there is a lot of importance. In NLP there is a lot of importance for language sounds and punctuations, and then other meaningful components. Do you agree with me? Language sounds have a lot of meaning in natural language processing.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, simply I say I'll ask the person go out. Simply I say get out. There is a lot of meaning in the language sounds, how we say. So in natural language processing, it can completely change the entire scenario or the meaning of the intention of the person who is speaking the natural language. Therefore, it is very important to understand them. Similarly, it is also equally important to study the language conventions and about punctuations, and then text markup and encoding. Punctuation is also very, very important, and everywhere it is commas, full stop, also it can change the entire meaning of that. I'll give a small example. Long back, there was a king, there was a person who was sentenced to death, and he was almost going to die. In the last minute, there is a person who approached the king and asking that the person is innocent, and he has shown some proofs or whatever it is. Then the king convinced, and he sent a message, because that time there is no mobile phone or no wireless devices. So he has sent a written message to the prison. He has ordered the prison in charge, stop, not hanging. Stop, comma, not hanging. Then you know where the comma was put. The comma was put after not. Stop, not hanging. Stop, not hanging. So these type of small text markups, punctuation, encoding are very, very important in the natural process. See, one comma has changed the life of a person. When you say stop, not hanging, stop, not hanging, there's a lot of meaning, right? So this is very important to understand. Of course, may not be everywhere you require, but where and all such a remarks are there, it is very important to understand it in the natural language processing. How the language is going to be understood by these people. Are you agree with me?
Yes. Yes, sir.
Yes, sir.
Yes.
Yes, sir.
But I don't mean to say go in depth and spend 1 year time on each and every subdomain, but the basics of this one, you need not have much time onto this one, learning the basic ecology concepts, morphological concepts, and some syntactic operations and lexical semantics is very, very important. Study of word meaning. This is very, very crucial. Lexical semantics is very, very crucial. The word has 100 meanings. What is the exact meaning in this context and in this scenario? So how to understand that? That has a lot of importance in the, possibly this is the high rated, prerequisite for you to understand first. The word meanings are changing, uncertain, ambiguous in natural language processing. And similarly, compositional semantics. Compositional semantics, when we talk about there is a word, there is another word, they have different meaning, and meaning of sentences when they combine and when they compose together. So these type of sentences and then compositions, how to understand them. Similarly, pragmatics, the study of the use of language to accomplish certain goals, like how we can use these sentences to represent certain meaning of a text. So all these things. So to achieve this NLP application, you should have separate, multiple phases of goals we have. First, tokenization, morphological analysis, syntaxic operation we're going to perform. Then semantic operations and using for some real-time analysis, and then the pragmatic. Everything we are going to see next. Multiple phases. It's not like one phase where we can simply take some formula and explain everything. No. So we'll start with morphological analysis, then we go to syntactic analysis, syntactic to semantic, and from there to pragmatic analysis, and finally we go for discourse analysis, where the final understanding of the sentence we can see. Many of you already studied, I think, right? Those who are studied, can somebody highlight what is okay? Let me first talk about what is morphological analysis. And here, what we do, whatever is the natural language data in any form, whatever is given in the form of some text document or whatever it is, I'm going to see what and all the individual words, and I'm going to see how they are analyzed to make some components, different components from the individual words, different words in some linear fashion, how we are going to understand. Then these individual words and the components which you have collected from the morphological analysis phase over the same document which you have taken, I perform some syntactic analysis, where I'll try to form some structures based on these linear sequences of words which are collected based on the morphological analysis. Okay, words to some linear sequences of words. They're transferred into some structures. Okay, so these structures will tell how these words are related and what they want to convey exactly. Try to understand. Okay, now in semantic analysis, we are making a transformation, okay, from the input text to an input representation. Meaning what? Some words to some sentences to some meaning of the sentence, semantic type, semantic in nature. Okay, So kind of transformation we are making from the input text to the internal represent. What is the actual meaning of that? Are you following me? Words to some sentences to some structures to the meaning of that. Okay, what exactly it reflects the meaning. Okay, then we are going to reinterpret. This pragmatic analysis is very important because in natural language processing, a lot of hidden meanings and hidden understanding, uncertainties, ambiguities will be there. Therefore, we are going to reinterpret it using this pragmatic analysis phase, whether it is really meaning of this one or something else by just seeing his the kind of features or structures what we have in the semantic analysis. This pragmatic analysis is very important. It may not be a frequent requirement in the natural language, but wherever it is going to see whether exactly this is the meaning of what we got from the semantic analysis, or any other hidden meaning is there from this text, which we can only understand after analyzing. For example, when you have some conversation with a person, you may not really come to know what exactly he wants to convey or he has any hidden agenda. When you can think of this conversation for multiple times, you'll have some new conclusion always. Okay, I have misunderstood his conversation. His idea was something else. His plan was something else. So when you can reinterpret it, that's kind of pragmatic study you're going. Okay. Finally, we're going to have the discourse analysis. What is the actual meaning of this one? And from words to sentence to structures to and final actual meaning to that one. So there are multiple stages of natural language processing. Every stage is a challenging task. Which stage you feel more challenging? Many have studied, I think, theory of computation, compiler design, and all
Sir,
this.
semantic to pragmatic is
Yes,
challenging.
these two, semantic and pragmatic, they are going to be very, complex because we are going from deterministic to non-deterministic type, or you can say uncertain type. Like it is something like what I can say. I'm going like known to unknown field. We are going here like words to sentences to structures and all. It is easy. It's like more or less like a compiler design type understanding and how a compiler can function by understanding that some tokens are whatever it is. Then when you go to semantic and pragmatic type, you're going from what? Like sentences to meaning to actual meaning. Therefore, these two known to be more analytical type. So here you may require a lot of challenges to face and then solve using some fuzzy logic or neural network type modeling, etc. etc. Okay. Any doubts so far?
No, sir.
Sir, sorry
No, sir.
to interrupt.
Yes, please.
Sir, is it always advisable to go through all these steps to get the proper result, or is it, for example, if I am asking Alexa or Google what is the weather today, and I don't think the NLP will process the entire statement. I think only tokenization and morphology will be beneficial, so I can skip some steps, right? So is it advisable to go through each and every steps to get the accurate result in NLP? Those are my
Sir,
questions.
actually speaking, now normally we have to follow these steps. When we talk about this, when we ask like Alexa, what is the weather condition today, or we can say how is the weather today. So, when we say weather is the keyword common, but the other
Correct.
keywords,
Yes.
other individual words are different. So obviously it has to make some morphological analysis, and which we are, that is like unseen phases which we have. But mostly, like you are right, in some cases, like I'm going to see some editorial article, I'm going to see whether he is going to criticize a particular party, some party X. Fine. First, I will say how many times the party is there. Besides that, like in the same sentence where the party name is there, fine, the same sentence. In that sentence, the other keywords components I'm going to say, I need not to see every words. It is possible. You need not go through every time, but at the same time, when you go this word by word, you will not be missing any crucial information or features or components in the text. That is the actual meaning of that. Wherever it is, you have some, actually there is something called key phrase extraction. Key phrase extraction. So that actually we are doing now. When we take some editorial articles of some 10,000 words, you don't require all 10,000 words to make all this actual conclusion, the final phase. But actually, you may require only 10 or 15 crucial words or some 10 or 15 crucial sentences known as key phrases. If you can manage to extract those key phrases, we are already done. But to extract them, you may require all these steps first. Agreed, sir?
Okay, sir. Yeah, makes sense.
Right?
Makes sense, sir.
So
Thank you,
when
sir.
you say even Alexa example also, mostly it will go with some kind of token, what and all they require. But at the same time, it
Correct.
will also see the other part, what exactly the context the user is speaking. If it not, I mean, if it is not following all these protocols, somewhere it can miss up some important, like I already mentioned, even one comma can make a difference in the natural language processing. Therefore, it is better if you have no computational problems, then better to follow all these basic like word to structures to sentences and everything. And of course, I agree with if there is a large volume text data, like some real-time collection of some data, like some for some defense application, I'm going to have some surveillance over the emails of large volume of customers. Therefore, obviously, what happens, it is difficult to make word processing each word by word. So there you can go for some kind of tokens or some kind of keywords. Then you can see the neighboring natural language text. That cut short you can do, that is always there. Okay. Okay, so to give a simple answer to
Sir,
your question, it may be done with some key features, but the feature extraction is challenging here. If you can manage to get the key features, you are done. Your point is right. But if you miss some key features, it can give some wrong classification at the end of it. That we have to take care. Yes. Other doubts?
sir, could you please explain discourse analysis with a basic example?
Basic examples. One second. Let me take with some e-commerce application I'm going to have. For example, I'm going to see some item. Fine. I'm going
Yes,
to
sir.
see some item. Then what I say, I'll just, if now, of course, now we don't have Amazon or Flipkart, they're not providing any voice assistant services. Just we are, they're only mostly going with some recommendation system type based on user choice. So assume that there is a voice assisted recommendation system with NLP processing that can help the suitable items or goods which you are going to order or procure or purchase. Then normally say like I would like to see some casual wear. I would like to see some laptops of some Dell company or Apple company with some i5. Just it will collect all these individual words and some kind of sequence it is going to sequence of words, and which we are going to transform into some structures. What is the structure here? Some laptop, some i5, some what you call like a vector type, some
Yes, sir.
laptop, i5, and then price some 70,000, etc., etc. Now, from this, the semantic analysis, what you're going to do, you're going to make a transformation to from the input to the external representation. Means what? What is the internal representation? He wants to buy a computer or he wants to buy a laptop, whatever it is. So the representation is overall he wants to buy a computer and
Yes, sir.
of set and range. In this pragmatic analysis is what it will like reinterpret whether he wants to buy a computer or iPad. What is the exact meaning? He's searching for some kind of processor, some kind of computing device, whether it is really maybe he's searching for Amazon Kindle or iPad. Exact. I mean, not at the same example, but just roughly I'm just talking about. It will reinterpret what exactly the actual meaning he wants to convey here. Then based on that, now some kind of discourse analysis finally will be between the sentences. Like I'll make based on my conclusion, like I would like to have a computer of set and range, set and range, set and range. Finally, some final analysis can be made, and we will say this is a possible item he is looking with some high chance like 90%, then 80%, 70%, like that. So here what happens? Finally, the sorting happen with respect to the available items or goods in the e-commerce application. Like this particular user, based on this vector components are the structures we have developed, and based on this understanding, he's going to purchase this type of items of same category. If there's other category, then we can have some reference for this one and go to the next level. So normally this type of application we can use with some recommendation systems or not. Similarly, other example. So once the pragmatic stage is done, we have a clear picture. Okay, what exactly we can do? Then we can resolve for some references. What do you mean by references? See, resolving
Like IP.
references between sentences. Now see, we have different sentences we are going to see, and we are going to understand this particularly corresponds to what exactly, it is the expectation, whether there is any conflict is there or not. Then finally, what is the recommendation or conclusion we are making out of this one? Different phases. It is just like a protocol. If you can see, it is simply the input was to the structures to the actual meaning to the final conclusion we are making. right? But actually the same, the type of understanding can change from application to application here. Somewhere only NLP processing you can use, somewhere you can have NLP processing with some recommendation systems or with some other digital signal processing type application you may require. Of course, we have other examples also in the next slides. Any other doubts?
No, sir.
Mostly, please focus on the semantic and pragmatic analysis where the analytical challenges will be there on real time when we go with. And particularly this type of real-time data, when the user is searching for an item in e-commerce application, you cannot wait for 1 hour that you to give a conclusion. That is a real-time recommendation you have to make based on the natural language processing you have taken from the user. Fine. From the data what you have collected from the user. Therefore, it's a real-time collection of real-time analysis, real-time processing you are making. Therefore, it's very, very important. For such a system, you should have even high accuracy. Like when you are searching for item, if some irrelevant item or completely different item is coming, I'll simply close my browser, right? Therefore, it is very important, concerned with a lot of revenue and other issues also. Okay, so this type of I think we have close. We have another. Now, this information extraction or key phrase extraction is one of the important challenge here. How we are making or using. So I think the same example, like I mentioned in the previous slide, how we are going to create some document, and then once the documents, the data is collected, whatever the form it is, then what is the information extraction model we are using? Segmentation, classification, association rules, some kind of, because association is also very important. Sometimes user recommendation, when he's going to buy computer, I'm going to buy antivirus also. So all these this information extraction with some possible association between the sentences and correlation, dependency, all these things we have to understand. Then there is a query database. Based on that, we are going to process the actual information. No, I think I already answered this, why it is very hard, everything and all. Mostly it is natural language is ambiguous, and scaling issues also is that we have always challenging. Now my question is ambiguity. Anyhow, we have talked about scaling. If you have a NLP model, like there is an efficient model, an accurate model, that will mostly say what exactly the meaning of the natural language processing, and the application is fine. Now, if I scale the data, like some more natural language is added and something, the scaling problem we have. Now, do you expect the existing natural language processing model to work on the same type of data again? I mean, the scale, once it is scaled, you want all the NLP models to be scalable always? Tell me. Say yes or no, please. Can you hear me?
Yes, sir. We
Yes,
can hear
sir,
you.
we can hear you.
Yes,
Yes, sir.
Are these scalable always if you have any NLP models?
I'm not sure, sir.
Need not be. So they may not be scalable. They may not be scalable. Okay,
Sir, could
scalability
you?
is another issue. That's why NLP is hard. Like if I have a good model where I can use some 90-95% accuracy, if I scale, I mean, if I have a different type of data or some more real-time data is added, if we go with some incremental type of database, whatever it is. So it cannot be scaled to some large environment. May not be. Not I can't say cannot be. May not be. Okay. And similarly, many others, sparsity, variation, and then variation, I mean, the type of data, expressivity, and then because according to that, and then unmodeled variable, there's a major problem we have NLP. If you have not, I mean, if you are facing like what we call, there is some word, uh, unknown query or untrained type databases, when it is encountered, it may not work. Unknown representations type, everything. And the major challenging parts of the natural language processing, segmenting text into words, and because it is very important how we are going to segment the text and going to make some crucial words with that. The morphological variation, how to understand, I've already explained. Then words with different meanings, then how to interpret what is the exact context or exact meaning in which context the user has spoken the language. There's some domain specific meaning. Some words have domain specific meaning. Some technical keywords are there, how to understand them. And then multi-word expressions is very dangerous in natural language processing to have some wrong conclusions unfocusedly. So there are plenty of options we have how to deal with ambiguity, and we use some different non-probabilistic methods, etc., and many other probabilistic methods also. We have hidden Markov models and other type of plenty of them. But anyhow, they are different, and how to deal with explicit. There are challenges. I'm just talking about. Similarly, unmodeled variables, how to deal with, and like I mentioned, one of the solutions could be like probabilistic NLP type models, where I'm going to make some rule-based NLP. Mostly like rule-based data mining processor, very easy, because if you can come up with the proper or accurate rules, it is easy to make the conclusion what is the exact meaning of the natural language that we're dealing with. Mostly in 1990s or other previously, if you can have. Now mostly statistical NLP we are using, because with the flavor of machine learning coming to the picture, or before that, this type of translation models and ranking models to deal with features, etc., they're coming plenty. Of course, a lot of time takes to explain. Now, fields like where and all we can use this NLP, machine learning, linguistic analytical processing for some psycho-socio other type of analytical modeling, cognitive science type applications, information theory. Of course, we can process the information and then see what is the exact meaning it wants to convey. Logic, uh, other data science. Obviously, we have seen political science, sentimental analysis, psychology, mental state analysis of a person, mental state. I mean, this uh, other psychometric analysis of a person, in some economic type application. Plenty of applications we have. Most of the other application we have to develop some conversational agents and having some information extraction question answering type models to develop. This is one of the most important, application we are having with NLP. Then we have machine translation. That's also very important. Like we have language translation, other type of modeling, language conversations, and language understanding type models. Then sentiment analysis, opinion mining and sentiment analysis type problems. Then we have social media analysis. What is the text in the social media? What is the input? Is it not a natural language? The entire, data for social media is actually is natural language. It is easy to make all the NLP model to understand. We can predict the behavior. We can predict the uh, type of the persons based on the social media data. Then visual understanding and some evolution of some editorial or some essays, etc. And seeing the scholarly article, literature or articles, and this plagiarism and other type of document processing applications. Because looking into scholarly literature and seeing that whether it is really standard or not, because unless we read the entire article and understand in depth, we cannot say. So how to mining this scholarly article, medical article, legal articles, legal literatures is very difficult to have come. If you give it a NLP application and simply give us an input to whether it's a legal document or some scholarly document, some kind of published paper, we can say exactly some kind of conclusion about that. Fine. So all these applications we have to this. Now, if you go with the plagiarism identification, like if you take a particular key phrase or some para where a person is rewriting in a different language, still if you go with an efficient natural language processing application, we can see what actually, similar representation is given in a different source of paper, where we can say that the content is to be plagiarized or reused. Other applications and some examples. Since we have no time, I'll just ignore this. Other activities, syntax and machine learning. I'll just ignore this. Just one of the important things, like most of the research is going on in the NLP side for some human computer dialogue systems, how we are going to deal with them in this type of modeling. Mostly what happens here, we try to have a computer modeling where it can understand the human behavior, I mean human dialogue system, I mean the natural language from the different users, maybe at the same time or different times. Here, this system mostly we expect for some conversational types um, with some linguistic processing, and then for some discussions with a particular workstation or a computer, and some maybe teaching or some treatment or etc. etc. So normally how it works, human machine dialogue system. Uh, can you see the figure? That human machine dialogue system.
Yes, sir.
See, normally, like I have some voice input signal, like we call it as like our text, natural language text, or some speech, whatever we have converted into. So how we are going to convert into some text document or some kind of features. So first, what we do, we convert the spoken text or spoken signal, spoken language, spoken input into some document form, some text form. Okay. Now, who will do this? Converting a voice input signal to some text form, some document form. Normally, there are some speech recognizers. If you can see, to open your laptop or computer, we have this speech recognizer, right? So, speech recognizer converts this given spoken, I mean the spoken audio input into the some document text. Okay, then whatever the converted text and document form, it will be fed to some language analyzer. Normally, what is the role of language analyzer? Language it try to get or deal with or extract the actual meaning from the text. Are you following me? It is easy to convert the given input signal, audio signal, to some text form, and then it is easy for you to extract the meaning from the text. So language analyzer will do after speech recognizer. So recognize the speech, convert into text, then go for language analyzer, which will help see the what is the meaning of that. Now meaning, what is the meaning again? Which form it is? Again, it is some document or text form, maybe some tokens or some key phrases, whatever it is. It's a kind of text form, natural language form. Now, this I'm going to again give it to your workstation or computer, whatever it is, where the query processing can happen. So these queries are database processing where you are going to have and make some replay from that to the user, because computer understand what is the user requirement from his voice input signal after converting into text and after seeing what is the meaning of the text. Then the meaning it will create a replay. Okay, after seeing the queries database. What is the queries database? It will tell serial number 1, query 1. This is a possible replay. Query 1 for type of patient, so on so. It is a possible replay. So after seeing the queries database, it will construct a replay in text form for the meaning which you have understood from the language analyzer. Okay, and again we require a speech synthesizer, because now when somebody is asking orally, we cannot give a written form. So what we can do, we can also again use some speech synthesizer which will convert this text replay from the workstation, which takes the replay or to the answer to the user query from the query database. Are you following me? So this text replay, whatever is given by the workstation from the query database, fine, to the given input option from the user side, that will be converted as a voice signal or voice response from the speech synthesizer. Now, finally, that particular speech is given to the user as a voice output signal. Fine. So this entire protocol, how it goes from, goes as an input, as a voice input to your system, your hardware and software system, what you have here integrated with. That with the help of this speech recognizer, language analyzer, and the query database, which we are using to generate the actual replay for the user input text, which we are converting into the speech synthesizer. Into a voice output signal using speech synthesizer. And finally, user will hear the noise or the sound. User will hear the answer to his query. Okay. Now the query database, like how you are going to train your neural network model. For query one, what is the answer? Query two, what is the answer for a type of patient? If the patient age is of something, for a particular query one, this is the answer. If age is something, this is the answer. If age is something, this is the answer. Then query two, something like that. Query three, something like that. Okay. So this is very important. How we use these speech models and then semantic models and then this information database. Finally, to extract the actual audio output signal to the user for the answer to his question, which was asked in the beginning, to the human computer dialogue system. This is a real time. This entire process mostly should happen in the real time or with some small delay. Okay? So these type of human computer dialogue systems are very, very popular. They can be used for online teaching, patient monitoring system, e-commerce applications, and then and many, many other places. Okay. Any doubts?
No, sir.
So I think we are almost done. Another 5 minutes we have. Just let me finish quickly. So what is the current I mean, different type of existing dialogue system, how they are working. Normally they have simple voice communication with machines. Currently what we have, actually speaking, I mean, whether with or without NLP, but still what we have is currently the type of voice assisted systems, voice communication machines, where we have like some personal computer type models, some interacting answering machines, like some, if you go and like you're going to book something, you once you say something, it will understand and it will ask you to give some small response in the form of some text. Then voice dialing of mobile telephones, yes, obviously it is there. Then vehicle systems, it's again very, very important. Have you heard of these autonomous vehicle systems? Anybody?
Yes, Tesla.
Yes, many. Now we know the key role of natural language processing there, because most of the smart vehicle systems like them, obviously we should have a kind of natural language processing systems where it can understanding the owner of the vehicle and his, I mean, of course, his voice, and according to the input commands from the owner of the vehicle, it can take the possible actions like start the vehicle, stop the vehicle, and to different modes of the vehicle, etc. So how this, and of course autonomous vehicle system, exactly where we will say it's a long way to go to complete with a detailed NLP type application, but for the time being, NLP for some vehicle control management system. Okay, for autonomous systems still time is there, but if we are using this NLP obviously, but at the same, like we can control from here a particular vehicle which is having, I mean, no driverless cars, etc. But for now, we are going like voice assisted systems in vehicle, which you can control. I mean, you in the sense the owner of the vehicle can control. Okay, and similarly, you can also for some accessing the information and some data repositories, etc. And this is a current, I mean, the features, etc. Similarly, there are plenty of other uh, research is going on developing some high-end sophisticated dialogue systems which can cover for any user queries and different type of users and for various other applications what we have discussed, etc. What is the future of human computer dialogue system? What I'm speaking now, like seamless spoken interaction between a computer and user, obviously. Like now, if you skip on, like, see the performance or the limitation, whatever we talk, both performance is limited, and the limitations are obviously, it's a never ending with human computer dialogue system. After a certain stage, it may not give an answer, it will say I can't understand. But because if you keep on testing, if see, it is like interviewing the person in the interview. How brilliant the person is, if you keep on doing the interview for 1 day, 2 day continuously, one day he will stuck, he will not be able to answer, obviously there is an end. So similarly, this like a seamless interaction when we are trying to make a computer and human, our job is to take it as large as possible, this is a seamless interaction. Okay, and obviously, like integrating a lot of AI technologies and make it some highly accurate testing machines we are going to develop. And over the time, if this will go to some highest peak, a computer can be a good teacher. I mean, when you say good teacher, in the sense, it can play some role of a teacher, some amount. and it can cover certain topics to be taught by a workstation or a computer, and where we can have the user experience and see the feedback from the users, like that. A lot of it. Not only this, just a couple of them I'm highlighting. Similar, there are plenty of other application. This is only I'm talking about human computer dialogue system where we can use the natural language. Similarly, the other applications in NLP is endless. Fine. So there are some problems also. Anyhow, we are talking about many other application like unexpected and then untrained responses are given to the human computer system where it cannot understand the natural language and it can give some obvious response obvious when there is not understanding of something and other reasons. So that's all. Any other questions, please let me know. I think I'm done now. We have completed. We have another 2-3 minutes left.
Sir?
Yes.
Sir, in one of the slides, we were taught that NLP is hard because of the scalability. Could you please explain that again? How?
Yes. Now, when we talk about scalability issues in NLP, uh, scalability with respect to different views we have. First of all, I'll say, now I will take a, now when you say NLP, we have a problem of scaling. Now assume that you have developed some modeling based on some deep learning based application or some extreme learning machine or some genetic algorithm based NLP application. For some, let it be like some sentiment analysis application, like you are going to take your model is going to take some editorial article or some newspaper article or some newspaper coverage as an input text, and it is going to give some prediction like something like this is a possible meaning or conclusion of the sentence, this is a possible like sentiment of the people based on the last 3 months coverage of newspaper, whatever it is. Then what happens if I take same modeling, if I go with like different type of data, if I go with some newspaper data plus Twitter data, Facebook data, some social media data, whether the same model can be extended to the other type of data in the same application, for the same application, I want to say the sentiment analysis of the people. Fine.
Yes, sir.
So when your data is particular type of data, now if I can go with a different type of data, whether your model can be scalable to other formats of the data, but of course it's again a natural. Type of representation unit, Twitter handles are different, Twitter tagging is different. Therefore, how you can use your model for that type of data, whether scalability with respect to different type of data, or again scalability with respect to the size of the data and all other.
Sir, your voice is not audible actually.
No, I'm audible. I think but there is some noise from other side. Can you hear me now?
Yes, sir. Now it's fine.
So what I was saying is, if at all there is any efficient or accurate NLP model, we cannot guarantee that it is always scalable. That's what I mean highlighted there. Okay.
Okay. Yes, sir.
Okay. Any other doubts?
Sir, Sir Prabhakaran here. Sir, any tools can you suggest us, or what type of libraries can we use for this?
Pardon?
Sir, actually, to develop any application, any tools can you advise for us, and also can you please tell us?
Please, you're not audible. I think there is a lot of background noises coming from your
Yeah,
side.
1 minute, sir. 1 minute. 1 minute. I'm very sorry.
Can you repeat,
Sir?
sir?
Yes, sir. Sir, for all these works, any tools can you advise for us, or any also any libraries are available for this to further development on that particular part? Any
No,
like
see
you can see the fields like
different tool, what and all the machine learning tools you have here, you can use for the existing. Now your only input here when you go for NLP, the beauty is only the type of input data is different. Maybe it could be a voice signal, or it could be some text data, document data, or any other type of Twitter type data, whatever it is. But existing all the machine learning toolboxes, everything you can use here. That is advantage here. because here it is not a programming language or any other by machine language you are taking as an input to your model. Natural language you are taking, once you go with all this tokenization and all this lexical analysis and everything, you can use any machine learning toolbox, whatever you require here.
Okay, sir. Okay.
But the platform you can change it, whether you go with Python or MATLAB or R or Veka, it is up to you. But the platform you can choose. But this is this type of NLP application you can implement most possibly in any of these platform, Python or MATLAB, whatever it is.
Okay, sir. Okay, fine. So, thank you very much, sir.
Okay, I think we are done. Thank you. If you have any doubts, still you can mail me. My email ID is there, everything in the NIT Goa web page. That's all from my side. Thank you very much.
Thank you so much, Dr. Reddy,
Thank you,
sir,
sir.
for the lecture.
Thank
It
you,
was
sir.
quite enlightening and incredibly informative. I
Thank
would
you, sir.
like to inform all the participants that we will commence the next session with another speaker from 6:10 p.m. after a small 10-minute break. You are requested to please join back on time to avoid any delay. Thank you, sir.
Thank you. I'm leaving you. Okay.